Hello and welcome back to some more Math 120. We are getting into chapter 7 now, which starts getting into algebra. So first thing we're going to look at is a particular type of algebraic equation, which is going to be limiting as far as what we're tackling. So let's jump right in. So we got linear equations. Now, before we get into solving linear equations, the first thing is we have to define some terminology. So an algebraic expression is a representation of the basic operations on any collection of variables or letters and numbers. So if we have 6x minus 2, really all we're saying is 6 times x minus the 2. So we have two different operations in there, and we have some letters in there which are called variables now. 3 minus the square root of y, 2x to the second power times y, all over z to the third power. So we could have all kinds of different expressions, but what makes it into an equation is when we slap an equal sign in there. So statements that suggest that two algebraic expressions are equal are called equations. In particular, a linear equation involves only real numbers and one variable throughout, with each instance having a power of 1. So we're not going to have these complicated things with a lot of exponents on those variables. So yay! So that's a big one. Even though this doesn't explicitly have an exponent, technically in math terms, it does have an exponent other than 1. So we're not going to see those types of things either. So what are we going to see? Well, 6x minus 2 minus 2 equals 4. Y plus 5 equals 3. K plus 1 equals 10 minus 2k. So even though we have multiple instances of this k, that's all right. So we're going to have problems like that as well. Now, so the equation 6x minus 2 equals 4 is considered a linear equation in x. So again, the variable has an exponent of 1. So even though there's not an exponent on it, technically there is an exponent of 1. Just like you can put a 1 in front of the x, you can put an exponent of 1 and it doesn't change it. So which equations are linear in x? Well, this one has an x, which is good, but the problem is the exponent. So this is not linear in x. What about the second one? 3 equals 1 minus x. Well, x is in there, so that's good. And it doesn't have an exponent, which means it has an exponent of 1, so we're good there too. So this is linear in x. And the last one, well, right off the bat, they got a y. So we don't want a y. All right, so this is not linear in x, but is linear in y. So that is the difference. So it's linear in y. All right, so let's move on to the next part of this. So we have a sense of what equations look like, but now what do we do with them? Well, we're going to want to solve them. We want to know what makes those equations true. So that gets into the solution. So a solution of an equation is a value that satisfies the equation when substituted in for the variable. So 1 is a solution to 6x minus 2 equals 4. Why? Well, if we plug it in. So again, we're going to replace x with the 1. Now, when you replace a variable with a number, you always want to use parentheses. So we want something like this. So that's the question. Is 6 times 1 minus 2 equal to 4? The answer is yes. If we use the order of operations, we would multiply first. So you get 6 minus 2 equals 4. And so that means 4 equals 4. So we're good. We can also say that 1 in curly braces is the solution set of 6x minus 2 equals 4. So anytime they put those curly braces around it, it just means it could be one number or it could be multiple numbers. Now, for our equations, it's either one number or an infinite amount of numbers or no numbers. So typically we're going to just see one number in our solution set. We're going to see those other cases of equations a little bit later though. So what does it mean if two equations are equivalent? So now we get into the process of how do we solve equations. And the trick is going to be to do some modifications to it to make it into an equivalent equation. So because when they're equivalent, they have the same solution set. So if we're just doing some cosmetic changes to it throughout, and we get it down to a very easy looking equation that we know the answer to, then that boils back to the original problem. If we know the solution down here, it's the same solution up here. So we're going to see that in action. So we got a few different cases here. So 6x equals 6, 6x minus 2 equals 4, and x equals 1 are all equivalent equations because they all have the same solution set of 1. 1 satisfies every one of these problems. So in order to transform into equivalent equations, we can use two properties of equality. So let's see what those properties are. So the first one is the addition property of equality, which basically states that if you have an equation to start with, you can add the same thing to both sides of the equals and it's still a true equation. So think of it like a balance scale. It's balanced to start with, so if you add weight to one side, you better add the same weight to the other side to keep it balanced. Otherwise it's not balanced. So that's the idea. You're going to add the same thing to one side as you do the other. Or you can subtract. And so if you subtract from one side and subtract from the other side, it's got to be the same amount. Otherwise it gets unbalanced. So that's the idea. So we'll see that in action. Multiplication property, very, very similar. If you have an equation to start with, you can multiply the same thing onto both sides and it doesn't change the value or the equality at all. It's still equal. And similarly, you can divide off of both sides as long as it's the same thing and it keeps the equation balanced. So let's see a couple of problems in action and then we're going to jump into some bigger ticket problems. So 7x plus 8 equals negative 1. So now where do we start? Well, we want to look at the side that has the variable and we want to get rid of all those pieces that are attached. So we want to get rid of the 7, we want to get rid of this minus 8. But which one do we do first? Well, it's a little backwards from the order of operations. Order of operations, we will parentheses, exponents, multiplication, division, addition, subtraction. Well, when we're solving, it's almost reversed. We want to take care of things that are added and subtracted first, and then what's multiplied and divided last, or well, next in the list. So let's see how that works. So if we have a minus 8 here, and we want to get rid of that, we want to undo it, what's the opposite? You want to add. So instead of subtracting 8, we're going to add 8 to get rid of it. But if we add 8 to one side of the equals, we have to add 8 to the other side. So that cancels the 8's out on the left, and so the only thing left on the left-hand side is that 7x. So we'll bring that down. And then negative 1 plus 8 is equal to 7. So we've just transformed it into an equivalent equation. The answer to this equation should be the answer to the original. So now let's go one more step and make it even more simple. How can we get rid of this 7 in front of the x? When we've done this, we got to divide it. So if we divide both sides by 7, that cancels them out, and you're left with x equal to 1. So that should be the answer. So if 1 satisfies this one, 1 should also satisfy the original. Now you should check Checks are always a good thing. So if we plug in 1 for x, does this check? Well, 7 times 1 is 7, minus 8. 7 minus 8 is a negative 1. So negative 1 equals negative 1, and we're good. Now, if we want to do one that's a little bit more complicated, well, we have 4x minus 2x minus 5 equals 4 plus 6x plus 3. Now, the first thing you want to do is look at each side individually and say, is there a way I can simplify it on its own? So looking at the left-hand side here, we got a 4x minus 2x. So remember our fruit analogy. If you have 4 apples and you take away 2 of the same type of apple, how many apples do you got left? The answer is 2 apples. So combine those together first to get 2x, and then bring down the minus 5. Over here, though, we don't have x's that we can combine, but we do have numbers. If you got 4 plus 3, we can add that to 7. So that's step 1, is just to combine those pieces that go together, and exactly the way they're phrased to you. Now we're going to see that it can get a little confusing later on, but for now, just if whatever's on that side, just combine it as is. So now what do we do? Well, from here you've got 4 possible choices that you could choose from. Now some of you might say, well, I'm going to add the 5 to both sides. That's perfectly valid. Some of you might say, I'm going to subtract 2x. I'm going to subtract 6x. I'm going to subtract 7. All of those options are valid options. Now, if you want a concrete process to follow, here's what I would recommend. Start with your x's. Start with your variables, whatever they are. So that limits your choices. So am I going to move this 2x, or am I going to move this 6x? Well, the rule I would recommend is to always move the smaller of the two. Whichever one's smaller, move that one. So in this case, that's the 2x. So because it's a positive 2x, though, we got to do the opposite and subtract it. But if you subtract 2x on one side of the equals, you got to do the same thing on the other side. So now the 2x's cancel. You can bring down the minus 5, bring down the 7, and now you got your same apples. So 6 apples minus 2 apples is a positive 4 apples. And now we're similar to what we had over here. So now we want to try to get rid of all this stuff that's attached to the x. So what do we get rid of first? 7 or the 4? We better get rid of that 7. And because it's positive, we got to do the opposite and subtract it. So those cancel out on the right-hand side. Minus 5, minus 7. Well, that should give you a minus 12. And so now we're down to our last step, which is to get rid of that 4. So if we divide by 4, we get x equals negative 3. So with these problems, your last step should always be division. And we're going to see that. But you can see the last step was division, last step was division. So now as far as the check, we can plug that negative 3 back into the original and make sure it works, but I'm pretty confident it should work. So I'm going to skip the check this time. In general, checks are not absolutely required unless the book tells it's required. So do those at your discretion. All right, we're going to stop here and then we'll pick up the rest in the next one. See you in a minute.